Okay, so if you were told that you can cross multiply, you were told correct. But it's not always the quickest way to do things. Some of you might have seen the fact that if I multiply 5 times 3, I can get 15. That means, since we have an equal sign here, 4 times 3 makes 12. Everybody agree?
I agree.
Write down this one.
Yeah.
All right, so let's look at this example. 6 divided by 18 2/10, that comparison is equivalent to 9 divided by y. Well, doesn't 6 really make 3 times 2? And doesn't 9 really make 3 times 3? Can't I cancel a 3 off of each side? The reason is I can multiply both sides by a third. But I don't expect you to do that once you can see the fact that that's how factors work. Okay, so now I've got an easier equation. I've got 2 divided by 18 2/10 is equivalent to 3 divided by y. Is there any other comparisons I can really make right now? Not really, right? So now what would I do? Now you would normally cross multiply. Now I'm going to show you why cross multiplying works. When you cross multiply, aren't you just multiplying? Okay, let's look at it from a different view. What I'm really doing is multiplying by my denominators. Can't I multiply both sides by 18.2 and y? What happens? My 18's cancel on this side, my y's cancel on that side. But isn't that what I'm doing when I cross multiply anyways? The only reason I'm showing you this is so that you understand why. When you cross multiply this way, it's just like saying 3 times 18 2/10. Isn't that what I have here?
Yeah.
And 2 times y. Isn't that what I have over here? I just want to show you that why you can do that. Okay? Now what do I do? How do I solve this? Multiply by 2. I'm sorry, divide. I don't know why I said multiply. I'm just stuck on multiplication right now. So, y equals, go to the calculator. What is 18 2/10 times 3 and then divided by 2? 54 6/10. Originally, you would have multiplied 18 2/10 by 9 and then divided by 6. All right? If you were to do that on a calculator, could you tell me for sure that 54 is the right answer? No. Right? But can you look at this? And what's 3 times 18? He didn't divide it by 2. I said 3 times 18 2/10 divided by 2. 27 and what? Okay, good. And look, what we just did right now, that proves my whole point. When we saw 54, did that make sense?
Oh.
But if you had done this originally, would you have seen that it made sense or not? You wouldn't have known, right? But when you have smaller numbers like this and you break numbers down, then 3 times 18 we know is got to be lower than 60 because 3 times 20, right, would be 60. So 3 times 18 is going to be a little less than 60. Divide that in half, it's going to be less than 30. Is this a little less than 30? Yes. So did we do it right? You see what I'm saying? How it helps to break these numbers down to know if you're right or not. Because I guarantee you, if this was a multiple choice test, what do you think would have been one of those answers? 54.6 would have been one of the distractors. Okay? You guys believe me now? All right, let's look at something else. I'm going to really show you now why my way works better than the other way. Really knowing what numbers mean. So write this down. All right, so several ways to approach this problem. I think I will start by saying that 3 times 2 is 6. Therefore, 4x minus 5 times 2 must equal negative 26. That's one way to look at it. What's another way to look at it? I could multiply both sides of my equation by 6. If I did that, that goes away, and this just becomes 2. Isn't that exactly what I just said? 2 times 4x minus 5 equals negative 26. Same thing. Right? Which way do you like better? It's the same exact thing, right? So 2 times 4x minus 5 equals negative 26. Now what? No. Why would you make your life harder? Why would you distribute? You've still got, isn't this really 13 times 2? The 2's go away. Now you've got 4x minus 5 equals negative 13. You can almost do that in your head. But if you don't like my way, you are more than welcome to multiply 4x minus 5 times 6 and negative 26 times 3 and do all that math if you want to. All right, let's talk about these two triangles. Somebody tell me what this missing angle is. How do you know that? Because inside of a triangle is 180 degrees. Therefore, this missing angle must be 60 degrees. So this is called an equiangular triangle, and therefore it is equilateral. What is the missing? 60, which makes this an equiangular triangle. That means it's also equilateral. But is this side equivalent to this side? Why? Because, and this is specifically why, just because you have angle, angle, angle does not mean that you have congruent triangles. It does, however, mean that you have similar triangles. They are proportionally equivalent. Okay? So we're going to talk about that now. That's what this says. This is what the book, how they put it. Two polygons are similar if and only if their corresponding angles are congruent and the measures of their corresponding sides are proportional. Does it make more sense what I just said? Okay. Let's move on from that. Why don't you guys go ahead and write this down. You don't need to write all these words. Just write down the triangle. This is 3A. Okay, let's talk about these. Who can tell me what the missing angles are right here? How do you know it's 70 and 70? How do you know they're the same? Because the little dashes. Okay, it's an isosceles triangle, right? So that theorem states that if two sides are congruent, then their angles opposite are congruent, correct? Same thing over here. What does that make each one of these angles? 65 and 65. So even though these sides are congruent, does that mean that this is a similar triangle? No. Does it make it a congruent triangle? No. It doesn't do anything, right? Okay. It makes it similar if the angles are congruent, but the sides are proportional. And we're going to look at that right now. Write down these two triangles. All right, so can anybody tell me what the measure of this angle is? 40. And the measure of this angle?
60.
Good. How do we know that? Okay, I should have been more specific on who I was asking, but 180 subtract 40, 140 gives me 40. Okay, so far are these triangles similar? Yes. They have the angle, angle, angle. All right, now let's see if they're similar. So their sides need to be proportional. Now here's where it gets tricky. You have to compare apples to apples and oranges to oranges. So if I'm talking A, B, I need to compare A, B to R, S. And then I need to compare, pick one, B, C, wait, I didn't do that right. What did I do wrong? Pause, phone back on. I compared this side to this side and this side to this side. What should I have done differently? Exactly. I'm comparing AB to not this side of the triangle. I'm comparing this side of the triangle to this side of this triangle. It's easier if you just go ahead and write down the numbers. So we'll do that next. And then I'm going to look at BC compared to ST. Okay, let's write some real numbers in here. What's AB? 5 and 2/10. And what's RS? 3 and 9/10. Let's see if that is proportional to, what's BC? 7 over 5 and 2,500. Okay. Is it proportional? Somebody give me a figure. 5 and 2/10 divided by 3 and 9/10. Uh-oh. What's the answer to this? Who's got a calculator? What? 1 and 3/10? And the other one?
Can I get it?
Yes, please. So that means what? They are proportional. Let's write this one down. Okay, so I can say that these two polygons look similar. Why do I say that they look similar? Because of all the angles are congruent. A is congruent to R, B is congruent to S, right? All right, so let's go ahead, and it says the two polygons are similar. So I'm correct on that one. Write a similarity statement. Then find X, Y, and U, V. All right, so let's investigate a little bit here. 6 and 4, okay, well that one's easy. I can compare 6 to 4. Everybody see that? 6 and 4. So I'm going to put 6 on top, 4 on the bottom. Just because 6 is bigger. So I'm going to remember bigger over smaller. That's how I do it. should be proportional to, pick another one, x, x and 3, which one goes on top? No. Why did that go on top? Because it's bigger polygon. Could I have done it the other way around? Yeah, if I wanted to put 4 on top, I could have put the 3 on top. But I didn't. I chose to go with the bigger numbers on the top in the numerator. Okay? Now what? I don't see an easy way to solve this. Actually, I do. I would multiply both sides by what? 12.
Oh, I know.
Do you see why? Yes, you can just cross multiply. It's the same thing. It's going to take a little bit for you guys to... Please don't put... I didn't say that you didn't have to write it. I said you don't have to write it, but don't pack up because it's distracting. Okay, oh, I'm sorry, thank you. If I multiply both sides by 12, it's the same thing. Right? But actually, isn't this 2 times 3? And this is 2 times 2. So my 2's go away as well. So now it's just 9 equals 2x. So what does 1x equal? Did you guys get that when you cross multiplied? Okay. So it asks me to find x. It asks me to find y. How am I going to find y? Wouldn't I just set it up exactly the same way? Let's use a different color this time. So 6 divided by 4, isn't 6 divided by 4 really... So isn't it really 3/2? And what's y? Y plus 1 and an 8. Which one goes on top? 8 goes on top. Y plus 1 goes on the bottom. Right? Multiply this side times 2, and this side times y plus 1. Gives us, there's no easy way to get rid of this, so it's just 3y plus 3 equals 16. Subtract 3, subtract 3. What does y equal? 4.3 repeating. So then what was the last thing we had to find? UV. How do I find UV? Just plug it in. Substitute it. So if y equals, what did we say y equals? Y equals 4 3/10. So UV equals 5 3/10 repeating. And we're done.